Alright, so in this equation, we're dealing with circular orbit and finding the time period of a circular orbit of a satellite. So in this case, a satellite is moving in a circular orbit of radius, let me write it down, 9,000 kilometers around an unknown planet where the acceleration of gravity is acting on the satellite at 9 meters per second squared, going to the center of the planet. The time to perform one revolution is next to, so we're trying to find the time that it takes for this satellite to complete one full revolution. So now the first thing we can do is convert this value over here of the radius to meters. So it's going to be 9 times 10 to the 6 meters. And then we can keep the acceleration value the same. So the first thing we're going to need is to simplify the velocity into an equation. So the only equation we have for velocity is that the acceleration is equal to the velocity squared over the radius. And of these values, we only really have the acceleration because we don't have this radius yet. We can't plug it in yet. So we're going to do acceleration over v2 times r. We're going to plug in 9 is equal to v squared over r. And then when we simplify this, we get v squared is equal to 9r. So this is what we can work with when we're trying to solve for the velocity. So now to solve for the velocity itself, it's 2 pi times the radius over the time. And we don't have the time yet. So to rearrange this equation, the time would be equal to 2 pi of the radius over the velocity. So this is the equation that we're going to use to find the time of one revolution. So now when we start plugging in the value that we have for the velocity, I'm going to put it over here. T is equal to 2 pi r over the velocity. So now we have the velocity right here, but we have it squared. So let's try to put it in terms that it's only the velocity, not the velocity squared. So the first thing we're going to do is square root both sides. So we're left with v is equal to 3 square root of r. And now we can plug this into this equation. So t is equal to 2 pi times the radius over 3 square root of the radius. And this is going to end up being 2 over 3 pi square root of the radius times square root of the radius over square root of the radius. And this is because we're trying to get rid of the fraction. So we're left with t is equal to 2/3 pi times the square root of the radius. And now we can finally plug in all our values using this equation. So let me move down. And using the values that we have, t is equal to 2/3 pi times the square root of 9 times 10 to the 6 meters. And this ends up being 2/3 pi times 3,000. And this comes out to be around 6,000 seconds. So that's how long it takes for the satellite to complete one revolution. So now if we move up and look at the answer choices, we know that the answer is C, 6,000 seconds to complete one revolution.